Alright, so our group did matrices, and so the definition is that, it's a 2 by 2 array of numbers or functions, and it's really useful for systems of equations, so that's probably the most common thing you'll see it. They're written like this, and they have a size where A is going to be m times n, m is going to be the rows, n is the columns. So A here is a 2 by 2 with 2 rows, 2 columns. Can also be written like this, where you have B would be equal to Bij, where I is the rows, J is the columns, and here you have 2 by 2 again. So you can do a lot of different things with matrices. Addition is one of the most important. So if you wanted to add A plus B, you would do it by adding 2 plus 6, and that'd be the first entry. 3 plus 7 would be the second entry. 4, and you'd go on, and it would look like this, and your final product would be this matrix right here. So A plus B is going to be equal to C, or it can be written as Aij plus Bij would be equal to Cij. They have to be the same size in order to add the two matrices. So the rows has to be equal, the number of rows and the number of columns have to be equal. You can see some examples here. You cannot add D plus F, or you can add D plus F because these are the same size. You cannot, however, add D plus E because those are different sizes. Addition is cumulative, so A plus B is equal to B plus A, and it's also associative, so A plus B would be, or plus C is equal to A plus B plus C.
In multiplication matrices, there are two main ways you can do it. First one is just a scalar multiplied by the matrix, and the end result is just the scalar multiplied by each entry in the matrix. The other way is by multiplying two matrices together. But here, if you multiply a 2 by 3 and a 3 by 4, the 3's, the inside ones, have to match in order to multiply them, but the outside ones are going to dictate the size of the ending product matrix. So here, the 2 by 3 and 3 by 4 will give you a 2 by 4 for the product. Example of this, here we got a 2 by 2 and a 2 by 1. The 2 and 3 multiplied together, multiplied by the 4 and 7 added together, give you the 29. And the 7 and 8 multiplied by the 4 and 7 added together give you the 84. And keep in mind, multiplying like this is not commutative, but it is associative and it is distributive.
Another important thing you need to know about matrices is how to find the inverse. So say you have a 2 by 2 matrix and you're trying to find the inverse, you use row reduction and the identity matrix. Row reduction is where you multiply and add any two lines together, and the identity matrix is ones in the diagonals and zeros everywhere else on a square matrix. So say we wanted to find the inverse of a 2743, we take the identity matrix and put it on the right side, and by using row reduction we want to find the identity matrix on the left side. So by multiplying and adding by negative numbers or fractions if we need to, those two becoming row 2, and we keep doing this until the identity matrix is on the left side, and this now is our inverse. And this is useful so when we need to find a variable, ax equals b, we take the inverse and multiply it by both sides and make sure it's in this order. As we just learned from multiplication, order matters, and you will find your variable x.